Okey, aku record dah.
Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1G. So in this video, we are going to present about our project. The title of our project are Solar Wind Generator. We have 5 members in our group, which are Muhammad Fadlun Adli, Muhammad Irfan Hadi, Muhammad Haziq Iqmal, Muhammad Farhan dan Muhammad Danish Farhan. Next, we go to the table of content. Table of contents, we have introduction, material, processing and manufacturing, material and manufacturing process selection, financial plan, conclusion and reference. For introduction, the theme of concept for our innovation is sustainable technology. We decided to improve material that have been used for solar panel and wind turbines. Solar panel will introduce solar energy, will produce solar energy, radiation from the sun capable of producing heat, causing chemical reaction or generating electricity. For the wind power or wind energy, this use of turbine to generate electricity. Wind power is a popular, sustainable, renewable energy source that has a much smaller impact on the environment than burning fossil fuels. There are a lot of advantage when using a solar panel or wind turbine, which is first, both of them are pollution free because it does not contribute in adding any greenhouse gas into our environment. Secondly, solar panel or wind turbine can save a lot of money because electric will be reduced massively. Furthermore, the major advantage of solar energy is that it is a renewable source. Next, we go to the material.
Okay, so for material, for solar panel, we can use silicon or thin film photovoltaics. For silicon, photovoltaic PV cell, or also called a solar cell, is used as solar panel. When light shines on PV cell, the light may be reflected, absorbed, or pass right through the cell. The PV cell is composed of semiconductor material. Most commonly used material for PV cell is silicon. Silicon representing 95% of the modules sold today. Crystalline silicon cells are made of silicon atoms connected to one another to form a crystal lattice. The lattice provides an organized structure that makes conversion of light into electricity more efficient. Solar cells made out of silicon currently provide a combination of high efficiency, low cost, and long lifetime. For thin film photovoltaics, a thin film solar cell is made by depositing one or more thin layers of PV material on a supporting material such as glass, plastic, or metal. There are two types of thin film PV semiconductor, which are cadmium telluride (CdTe) and copper indium gallium diselenide (CIGS). CdTe is the second most common PV material after silicon, and CdTe cells can be made using low-cost manufacturing process. Even this makes them a cost-effective alternative. Their efficiencies still are not quite as high as silicon. CIGS cells have optimal properties for PV material and high efficiencies in the lab, but the complexity involved in combining four elements makes the transition from lab to manufacturing more challenging. Both CIGS and CdTe require more protection than silicon to enable long-lasting operation. For wind, for wind turbine, we can use fiber and polymer matrix. Glass fiber are available at a lower cost compared to their carbon counterparts and are thus more prevalent in industry. They are composed of mainly SiO2 and Al2O3 with other oxide present in small quantities because there is no crystallographic order. The material has an amorphous structure with isotropic properties. This means that its properties such as stiffness and thermal expansions are consistent along and across the fiber. Glass fiber are of moderate stiffness, high strength, and moderate density. Polymer matrix. The polymer matrix provides structure support by binding the fiber together and consists of two main classes, which are thermosets and thermoplastic. Thermoset contain polymer strong cross-linked together in irreversible chemical bonds. This makes them resistant to high temperature and remain in a permanent solid state when cooled. Thermoplastic contain polymers that lack this strong chemical bond so that interactions are reversible. The soften reheated, allowing for the possibility of remolding and repairs when necessary. However, this property also causes to melt under high temperature, making them impractical for some of the harsh conditions wind turbines must endure. Now we move to processing and manufacturing.
Okay, for now, processing and manufacturing. There are several processing and manufacturing process that has been identified to make wind turbine and solar panel. Firstly is extrusion process. Extrusion is a procedure that involves pushing material through a die with the desired cross-section to make things with a set cross-sectional profile. Its two key advantages over other manufacturing techniques are the capacity to build very complicated cross-section and the ability to work fragile materials because only compressive and shear stresses are applied to the material. It also produces a beautiful surface finish and allows for a lot of freedom during the design phase. Next is dry pressing. The main method of producing high quality ceramic component is dry pressing of technical ceramics. Uniform compact size and grain density, consistent part to part grain density, and defect-free compact are the goals of dry pressing technical ceramics. The axial compaction of loosely granulated dry ceramic powders that is less than 3% free moisture within a die punch system is known as dry pressing. Under pressure, the powder conforms to the precise shape of the punch faces and die. Powder compaction normally happens between the top and bottom punches of a rigid wall die. Anvil, rotary, multiple punch, and multiple action presses are examples of press configuration. Lastly, the pressing method. Pressing is not ironing. In ironing, the iron is pushed from one spot to another in an unbroken motion to remove wrinkles. In pressing, the iron is lifted up and set down in a particular spot to flatten or shape SMA to areas. Avoid using a sliding motion when pressing to avoid stretching the fabric. Next, we move to material and manufacturing process selection. Okay, for material and manufacturing process selection in solar panel, to maximize the usefulness of solar panel, there are some criteria that we must prioritize. A solar panel is a technology that we want to use for a long time because that will be our energy resource for now and future. So it has to endure for a long time. That is a main criterion for a solar panel. Second, a solar panel must work with effectively so that we don't have to face such problems such as an often maintenance, so that we don't have to disturb our energy resource. So based on the reason above, the material that will be chosen for solar panel is silicon. In general, photovoltaic PV cell, or also called a solar cell, is used as solar panel. Most commonly used material for PV cells is silicon. Silicon is a perfect for a solar panel material. Solar cells made out of silicon currently provide a combination of high efficiency, low cost, and long lifetime. For a manufacturing process is we must have to choose the good quality for a solar panel to operate. So we will choose extrusion or aluminum extrusion process for solar panel.
Aluminum profiles are virtually limitless in design complexity. This means that any likely engineering requirement can be met by tailoring the profile to suit the exact performance requirement. Aluminum is naturally corrosion resistant and forms a hard aluminum oxide layer when exposed to oxygen, which helps to deter further corrosion. So this process is perfect for solar panel operate for a long time. For wind turbine, to maximize the function of wind turbine, there are a few criteria that we must prioritize. A wind turbine also a technology that can be used to replace our current energy resource. Wind turbines have been used in a few countries such as China and United States. A main criterion for wind turbine must be having a long lifetime, so that it can operate for a really long lifetime. It also must have a corrosion resistance so that we don't have to replace it often. Way of wind turbine also must be prioritized. We will choose a lightweight material so that it will be easier to carry from factory to wind turbine energy site, and the wind turbine also can operate more easier with lightweight. Based on the reason above, the material that will be chosen for wind turbine is polymer material. Polymer material is a good material for corrosion resistant, so it can endure for a long time. They soften the heat, allowing for the possibility of remolding and repair when necessary. Then it also has a lightweight, so this material fulfills the wind turbine criteria. For manufacturing process of wind turbine, we will use compression molding to make our turbine. Compression molding is a popular manufacturing technique for composite parts. Compression molding is a high volume, high pressure method suitable for molding complex, high strength fiberglass reinforcement. Advanced, com- Advanced composite thermoplastic can also be compression mold with unidirectional tapes, woven fabric, randomly oriented fiber, mat or chopped strand. This process usually involves a large scale product, so it will be nice if we use to make a large wind turbine. Next, we move to financial plan.
Okay, next is financial plan for solar panel. Solar Solar panel typically work by converting light energy from the sun into electricity. Photovoltaic energy is created by using flat solar panels that can be affixed to a structure, roof or array across open space. Another method, known as thermal solar, uses a series of mirrors to focus the sun energy on a single point to turn water into steam, which then turn a turbine for consumer and business application. Photovoltaic solar panels are much more common than other types. The cost for solar power in 2019 was below 44 cents per kilowatt hour in all of the state record, and below 63 cents and 42 cent per kilowatt hour in some states. The national average for fossil fuel electricity was 55 cents. Prices are comparable, but the real saving from solar come in future years due to the 2.2% inflationary price per year for fossil fuel electricity. With solar, you are looking in cost at a constant rate. The only additional cost factor are the upfront cost of installing a solar system and the fossil fuel electricity cost needed when solar doesn't cover all energy needs. For information based on wafer in dimension of 156 mm times 200 mm and the thickness of 160 micrometer, around 11 grams per cell in 60 cell models, which are commonly used on residential rooftop that would work out around 660 grams of silicon compared to the average solar silicon price of around 34 ringgit and 80 cents per kilogram in 2020. This represents an increase of around 142 ringgit and 82 cent per panel, and with GST it will come to around 155 ringgit and 42 cent per panel. For our solar panel, we use a 370 watt panel with its common size this day. The price increase come to 3 ringgit and 75 cent per watt. Most solar cells are made from silicon, that the same semiconductor material that's in at the heart of computer. The cells are expensive to produce because it takes a great deal of energy to purify the silicon. The cost of using silicon is affordable, but the cells are expensive to produce because it takes a great deal of energy to purify the silicon. Next is a financial plan for wind turbine. For the material and supplies, the main equipment for the wind plant in the wind turbine, the power process for the grid and integrity system, and the tower. The wind turbine is an advanced technology that requires no scheduled maintenance and has a 5-year warranty with a design to operate for 30 years. The processor is also with 5-year warranty, requires indoor installation, and is fully automatic operation. With the processor, the excess power is sold to the ESM automatically. The next is engineering and technology. The technology used is the conversion of the wind's kinetic energy into rotating energy of the blades, and through the generator and the loss of electromagnetic finally into electricity. We can search for a wind turbine class of 10 kilowatt installed power given the meteorological register data. The BWC Excel wind turbine used the patented PowerFlex rotor system and satisfied the heavy operational condition storm protection. The warranty period is desirable. The start upwind in 34 meter per second. The cut in wind is 3.1 meter per second, and the rated wind speed is 13.8 meter per second. There is no need for training personnel and no need for professional startup and erection. This equipment can be ordered from the dealer in Bulgaria or directly from USA. For the table below, for equipment is wind turbine and power processor. We need 30. The cost for wind turbine and power processor is 80,000, and for the shack is 4,040 ringgit. 400 ringgit. Okay, next.
Lastly, is for the conclusion. In conclusion, the material that have been selected for our solar panel and wind turbine are silicon and polymer material because of the various reasons. And as for the manufacturing process, we choose the extrusion or aluminium extrusion process for solar panel, and for wind turbine, we will use compression molding to make our wind turbine so that we can maximize the good for both material that will be used. Lastly, we also calculated the financial plan or budget for this project in order for this project to be successful. That's all. Thank you. And the reference. That's all.